Let's apply some of the concepts we've learned about control and blocking to a new example. Let's say researchers are studying a new shampoo and they plan to compare the condition of hair for people who use the new formula with the condition of the hair for people who use the current formula. 12 volunteers are available to participate in this study. Information on these volunteers, numbered 1 through 12, is shown in the table below. So you can see that there are both male and females of a variety of ages in these 12 volunteers. So let's talk about how we might implement a completely randomized design. Well, in a completely randomized design, we could put the numbers 1 through 12 in a random number generator and generate 6 different random numbers between 1 and 12 and assign the volunteers with those first 6 different numbers to the new shampoo, and then the other 6 would use the old shampoo. That would be a completely randomized design. But some of you may be thinking, well, wouldn't gender or age maybe affect how their condition of their hair, and it might obscure the results of our treatment? We want to be able to clearly see the difference between the old and the new formula of the shampoo, and if there's a lot of differences in their hair condition based on gender or age, that would make it harder to tell if the treatments were actually different or not. That's where blocking comes into effect. We have some known variables that might affect the condition of their hair, so let's block. So let's start with a randomized block design. You always want to pick the variable that has potential to influence the response variable. For example, the number of times males and females wash their hair, or the length of hair, or maybe just genetic makeup of males and females might affect hair condition. Also, a person's age definitely affects their hair condition, with younger people tending to have oilier hair and older people with drier hair. So we could use either gender or age or both as blocking variables. So let's just say if we use gender, we would divide the group by gender. We have 6 males and 6 females in the group. So put the volunteers' numbers corresponding to all the males in one bag and the numbers corresponding to the females in another bag. Mix up the bags, mix up the numbers within the bags is what I mean, and draw out 3 numbers from each bag to use the new shampoo. The remaining volunteers will use the old shampoo. If you use age, you might want to divide the volunteers into groups based on age, maybe 3 groups, because we notice that we have 4 people in their 20s, 4 people in their 40s or 40s, it looks like, and then 4 people that are either high 50 or low 60. So we could divide them by 3 groups, the 4 youngest, the 4 middle-aged, and the 4 oldest, and randomly assign 2 from each group to the new shampoo and 2 to the old shampoo. Now what about a matched pairs design? If we actually want to use both gender and age, we notice that among the 4 youngest people, 21, 20, 23, and 24, there are 2 males and 2 females. And among the 40-year-olds, 47, 44, 44, and 46, there are also 2 males and 2 females. And among the oldest, 58, 60, 62, and 61, 2 males and 2 females. So if we pair up the 2 youngest females, which are age 20 and age 24, those would be volunteers number 2 and 10, pair those together, that would be a matched pair. They would be as similar as possible, same gender and nearly the same age. Then we'd pair up the 21-year-old male and the 23-year-old male because they are also very similar both in gender and age. We do the same then with the 2 middle-aged females, the 2 middle-aged males, and the 2 older females and the 2 older males. Each pair would be as similar as possible with the variables that we're familiar with. After you've paired them up, which I've described here, you'd randomly assign 1 of each pair the new shampoo and 1 the old shampoo. So what is the advantage of blocking? And this is really important, so make sure to star this in your notes, and you should print the notes out that go with this if you didn't get them in class. Blocking reduces unwanted variation so that the differences caused by the treatments can be seen more clearly. So let me explain that. Differences in hair condition could be caused by variables other than the differences in the shampoos. But ideally, we would like the shampoo to be the only variable affecting hair condition in our experiment. For example, gender could cause differences in hair condition, but if we block by gender and only compare females to females and males to males with the two different shampoos, we know that observed differences in hair condition are not because of difference in gender, because we've separated the genders. In the matched pairs design, we are comparing hair condition of two people of similar age and the same gender, so any change in hair condition is not based on differences in age or gender, but only on the difference in shampoo. So that's the whole purpose of the matched pairs, is within the pair, the only real source of variation should be the shampoo, and that way any difference we see in hair condition we should be able to attribute solely to the shampoo and not to other variables that were once mixed in this whole big group of people. Now what about blinding? Could this experiment be double blind? Yes. Okay, so when you're double blind, you have to double blind the people in the treatment, the people receiving the treatment, the people giving the treatment to the people, anybody associated with interacting with the subjects in the experiment. That's one group. The other group you have to blind is anybody measuring the results of the experiment at the end. In this case, they'd be people evaluating the condition of the people's hair. So the researcher behind the scenes does the random assignment of treatments and records which type of shampoo each person will use. So they do that behind the scenes. The individuals are sent identical looking bottles that have been pre-packaged by the researcher to have the correct type of shampoo for each individual, so they don't know which type of shampoo they've received. The person who evaluates the hair condition at the end of the experiment also doesn't know which treatment each individual received, but just reports the hair condition to the researcher, who can then analyze the data. Now, it's possible in an experiment like this that the individuals in the experiment would report their own hair condition. They might say, did your hair condition improve after using the shampoo? Describe the before and after of your hair condition. In that case, you couldn't make it double blind because there would actually be no separate person evaluating the condition. So, but if there was a person evaluating the condition, then that could make it double blind.